In this video, I'll show you how to prove trigonometric identities using the sum or differences of angles. This is question 4 in the series. The question asks us to prove the identity shown below. The first thing that you might notice is that this identity consists of simply cotangent and tangent. And there's a relationship between the two. Cotangent is the reciprocal function for tangent. So cotangent, let's call it cotangent theta, is equal to 1 over tangent. And tangent is defined as sine theta over cosine theta. That being said, if we were to replace sine theta, cosine theta into here, what you would end up with is 1 over sine over cosine, which means that cotangent is defined as cosine theta over sine theta, the reciprocal of tangent. Next, I'll replace all of these instances of cotangent with their identity. And if I do that, I'll end up with cosine y over sine y. Notice that the angle here is y, so we can't use theta, minus cosine x over sine x, cosine x over sine x, this part. The next part is cosine y over sine y, plus 1. Now, because I've dedicated to convert the left side to the right side, this part will remain the way it is, and we'll continue to transform this so that it looks like that. Therefore, we'll leave this part vacant for tangent x minus y. The next step is to find a common denominator here and find a common denominator amongst these two terms. Remember that these two are a product. The common denominator for the numerator terms is sine y, sine x. I multiply these two denominators together, and to find the numerators, I multiply this with that, this with that. As discussed, sine y, sine x, that's the common denominator, cosine y, sine x, minus cosine x, sine y, all over, and the denominator is here. We'll pretend that there's a 1 here. Sine x, sine y, we're going to multiply that to 1. That gives us sine x, sine y, which is identical to the denominator up here. And the numerators will be 1 times this, which is cosine x, cosine y, and this times that, giving us sine x, sine y. Given that these two quotients, the one up here and the one up here, both have the same denominator, if we were to divide them, their denominators would cancel out. And that's a fact. Now we're left with this part over this part. So I'll rewrite that over here, and you should end up with the following. Cosine y sine x minus cosine x sine y. Well, that's the sum or differences of two angles for sine. And because we have a minus in between the two terms, we have to replace the two angles with a minus in the middle. So the two angles that we have here is x and y. We'll replace this whole thing with sine x minus y because of that minus, while this expression in the denominator looks like the following. And if we have plus in between them, you have to choose minus. The minus will represent the symbol in between the angles, or the variables that represent the angles. Cosine x minus y. And remember what we said at the beginning when I said tangent theta is equal to sine theta over cosine theta? We can replace this whole thing with simply tangent x minus y, which, if you recall, this was in fact the right side. Therefore, the left side equals the right side. And that is how to prove trigonometric identities using the sum or differences of angles.